Dear children, now we will learn motion of a charged particle in a uniform electric field. You remember, uniform electric field is represented by equidistant parallel lines. So you see, it is a representation of uniform electric field. You see, the distance between electric field line is same. So if you place a positive charge, you know electric force F is equal to QE. As Q is positive, so from vector concept you can know if it is positive, force has the same direction as that of electric field. If you place a positive charge, it experiences electric force in the same direction of electric field. If you place a positive charge here, then it moves along the direction of electric field. Or if you parallelly throw, if you throw positive charge parallel to the direction of electric field, it will move along the direction of the electric field. Similarly, if you place a negative charge in the uniform electric field, then force becomes F is equal to minus QE. As it is negative side, so force has the opposite direction to that of electric field. If it is electric field direction towards right, then force acting upon the negative charge is towards left. So if you place a negative charge at here in the uniform electric field, it will move in the direction opposite to the direction of electric field. So now question arises, if we throw a charged particle in a direction perpendicular to the direction of electric field. Let us consider it is a uniform electric field and this electric field is uniform electric field is created between two parallel plates. One plate is positively charged, the other plate is negatively charged. So then a uniform electric field is created between the two plates. And here the charge Q, you throw the charged particle perpendicular to the direction of the electric field. So it is the velocity of the charged particle, initial velocity of the charged particle. Then you consider it is the you know the projectile motion. You can consider it is as the projectile motion. That is the projectile motion is under the influence of gravity, but here the motion is under the influence of electric field, but very similar to the projectile motion. So when the charged particle enter to the electric field, then what happens? You see, as here electric field, uniform electric field is in the downward direction, so the charged particle get a force, and as we have discussed, the electric force as charge, if it is positive charge, then electric force is in the same direction of the electric field, and if it is negative charge, it is in the opposite direction of the electric field. Electric force is opposite to the direction of the electric field. So now you consider this charged particle is negatively charged particle. As it is negatively charged particle, when it enter into the electric field, as electric field is in the downward direction, so it gets the electric force in the upward direction. It will be the force of the force acting upon the charged particle Q, considering this Q is negative. As the charged particle gets a force in the upward direction, so charged particle moves like this. But we have given the horizontal velocity in the velocity towards right. So in this direction there is no force. As there is no force, according to your Newton's law, the velocity remains constant. So in this region of this electric field, this charged particle has two types of velocity. One is your this horizontal velocity, which is uniform because no electric force acting in the horizontal direction, and another velocity, that is your vertical velocity, that is due to this electric force. So what is the force acting upon the charged particle? F vector is equal to QE. Then what will be the acceleration? A is equal to F by m. As F is equal to QE, then QE by m. Here you see the horizontal velocity or x component. If it is x axis and it is y axis, x component of the velocity that remains constant because there is no force acting along x direction. And vertical velocity, initially there was no velocity along vertical direction or along y axis, but gradually the charge particle gains velocity along y axis. That is due to the electric force which acts along y axis. So what will be the velocity along y axis after time t? Suppose when the charge particle reaches at here, then let its y component of the velocity be vy. Vy will be u plus at. As it is uniformly accelerated motion, you can put v is equal to u plus at. So vy is equal to u plus at. But initial velocity along y axis is 0 because this velocity we have given initially along x axis. But acceleration, that is QE by m, magnitude I have taken into t. But what is t? From this to this, the time taken by the charge particle is t. Then how can we find this distance? We have taken L and the velocity, that is uniform along x axis, that is v. Then t is equal to L by v. So Vy will be QE by m into L by v. So it is an x component that remains same as before, but Vy here QE L by mv. What is the resultant velocity here? The resultant velocity here, let it be Vr. Vr is equal to root over of Vx square plus Vy square. Applying law of vector addition. Here the angle between Vx and Vy is 90. So the third term plus 2 Vx Vy cos 90, that is 0. So it is Vx square plus Vy square. Vx is V and Vy is this. So it will be root over of V square plus QEL by mv whole square. So it is the resultant velocity at this point. Let this point be P. Now, what is the angle of deflection? Let it be theta, tan theta, that is P by P, Vy by Vx, and Vy is this, that is QEL by mv by V, that is QEL by mv square. Theta is equal to tan inverse this. So here I also want to find this vertical deflection y. How can we find y? You consider the vertical motion from this point to this point and put s is equal to ut plus half at square. So this vertical deflection, that will be y. Initial vertical velocity is 0 because this velocity is along horizontal direction, that is along x axis. 0 into t plus half acceleration, that is QE by m, and t just determined, that is L by v. L by v whole square, that is equal to QE L square by 2m v square. So here I can give one conclusion that this vertical deflection y, if when this electric field is uniform and L, V are constant, if charge particle injected with same velocity, then what happens? Y directly